Hello and welcome to episode 10 of Plants to Plants Hemp Processing Seminars by Sci-Fi Systems. Sci-Fi Systems brings industrial extraction technology into the future, and Plants to Plants brings top-tier experts to the table to inform viewers about what it takes to go from conception to completion on a hemp processing plant. Once again, questions are encouraged for everybody that's coming in right now. We will have a section to answer them at the end, and maybe a little bit if they're topical during. Today's episode is Making Moves, Conveying, Milling, and Drying for Hemp Businesses with Jeff Walling and Adam DeBose. The time for pallet jacks, ladders, and drying racks is over. As the hemp industry has grown, elegant, automated conveying and bulk handling solutions have become a must-have for efficient facilities. Join Sci-Fi Systems as we delve into many years of experience in conveying, drying, and milling hemp with Jeff Walling and Adam DeBose of ABM Equipment. Our guests today are Jeff Walling and Adam DeBose. Jeff is ABM Equipment's co-owner and an industry specialist with over 25 years of experience in all aspects of material handling. His areas of expertise span material handling, particle size reduction, weighing, drying, sorting, screening, inspecting, extracting, engineering, design and build out, and technical support. Our second guest is Adam DeBose, 20 years of material handling experience with a focus on material testing, product development, engineering, and product management. Adam's expertise covers numerous industries: wood, mining, 3A dairy, food, and of course, all aspects of processing hemp, including material handling, drying, and moisture content shredding up to biomass extraction. Thank you guys so much for being here. Our session today is, as always, hosted by the Sci-Fi CEO, Emmett McGregor, and I am going to go ahead and bring our guests and our host in right now. Okay.
Yeah.
All right, thanks so much, Edwin, for the introduction, as
Absolutely.
always, and welcome to Jeff and Adam from ABM Equipment. Thanks, everybody who has tuned in. This is an exciting episode, something that we're seeing a lot of action on in the industry and a lot of really first-time implementation for a lot of hemp operators that are trying to level up their operations and get to better scale, better efficiency. Really excited to be working with ABM on providing this type of conveying and particle size reduction and drying equipment. I know that we have a presentation today with a lot of visual illustrations of what we're going to be speaking about. So welcome, Jeff and Adam. Do you want to introduce your company at all anymore before we go on to your presentation?
You got that? Sure. Hey, Jeff Walling, I appreciate you letting us participate in this forum. ABM Equipment Company has been in the business for about 25 years. We specialize in bulk solid material handling. I always like to say that we like the dry side of the business. As soon as it gets wet, we kind of turn it over to Emmett and Sci-Fi Systems. We basically started out as manufacturing reps 25 years ago. We basically contracted to go out and sell individual components for processing systems. Since then, we have grown to a facility about 50 employees where we do complete engineered turnkey packages, specifically for dry material handling.
Excellent. All right. Well, I know that we have quite a great presentation here, so I'm just going to go ahead and bring that up and we can start digging into the subject matter. I'm going to ask that Edwin, if you could enable the screen share for me, that would be great so we can get the presentation going. In the meantime, I do want to encourage everyone once again, please feel free to ask questions in the Q&A and chat panels down below or above our video presentation, depending on what operating system you're using. We will answer questions that are on topic throughout the presentation.
Emmett, you should be seeing the options to do this yourself. Let me know if not, and I will go ahead and potentially steer.
It just came up. So here we are.
Excellent.
And so we just introduced ABM and Sci-Fi Systems. We will be focused on industrial hemp today. There are applications, obviously, in other spaces such as food, also in the regulated cannabis markets across the world. So we will start with an overview. So take us through from the start to the finish. You know, what do you see as being sort of a common setup for a large hemp facility? What are the front end stages that people may not really realize are part of what one of these systems takes to automate?
So as we first started dealing with this, with the hemp industry specifically, there was a lot of manual labor involved in getting it to and from the different pieces of equipment. The shortfall here was, again, the labor costs, but then also just the lack of control and inconsistency that a drying system needs. And so we, with other technologies used in other industries, we looked at different conveying and weighing and control methods to try to get a consistent dried product out of the system and to extraction, and also just to stabilize it, as it decomposes quickly. So conveying, if we start with that, that's our initial control point, is controlling the feed rate into the system so that all the rest of the equipment that's been sized specifically for a rate can handle that rate. Another benefit of controlling it is adding the ability to weigh it so that you know how much is going in, and then speeding up or slowing down equipment to, again, get consistency. So fresh product that's harvested as it comes in, typically, as we're seeing is for hemp, is forage harvested. It's long and fibrous, as everybody knows in hemp, that it's extremely tough and hard to handle with a screw conveyor. So we're using belt conveyors out of the gate to feed shredders. The benefit of the shredder is that when you, again, get into a homogeneous product, you want a more consistent size going into the dryer. But then also your options for conveying are opened up because you don't have the long fibers that create knots and entangled typical screw conveyors. So conveying, we've got the wet unshredded product is belt conveyors. After the shredder, then you can use, again, a belt conveyor or start using a more common screw conveyor to transfer from the shredder to the dryer. Is this belt conveyor? I think there's a video on one of them.
Yeah, let's see if I can get over to there. Yeah, there's the video, and this may come in a bit stuttered for our audience, but you can see here on the left side, that is a belt conveyor. I believe, if I'm right, that's a trough type belt conveyor, so it has a low point in the middle to prevent any spillover on the edges there.
Go ahead.
That's coming through.
Something that's very important to note on the in-feed belt conveyor, as we bring the product in from the field, some of the primary questions we ask as we start to look at a project are we doing a whole plant chop, or are we bringing that in at half cut, 1/3 crop top, or is it being hand bucked? Depending upon how we're receiving that product, that trough belt could have several different accessories. We could get to the point where we'll have an in-feed hopper on there that will actually have what we call a motorized leveling weir, where we will actually be utilizing that to help maintain product depth on that in-feed trough belt. Typically, on some of the larger operations, we actually have operators that use bobcats and front-end loaders to load that hemp into the original first part of that process. We consistently need to feed the second part of that process off of that troughed belt, which is the shredder. And if you overfeed that shredder, and these shredders are designed to eat cars, hemp will actually stop it if you actually overfeed those and plug feed your shredder. So it's all about consistently maintaining control of that product from the minute we hit that trough belt all the way through that process. So that's critical on that trough belt. So we actually, what you're seeing there is actually a trough belt that is actually being metered and monitored by an individual to the point where we can get it totally automated, that we can actually have a bobcat drop into a hopper, and then we'll have basically feed screws that feed that product right onto that belt with a leveling weir on top of that. So we can get fairly complicated depending upon that process and what people are looking for.
And the big thing there, of course, is that by eliminating a single person responsible for making sure that you're getting consistent feed, you're eliminating that human error potential, where where oftentimes if we
Absolutely.
can eliminate a person that's supposed to be monitoring a process and have it be truly an automated process as far as leveling and getting a consistent flow through, you have a lot less error in the works. Obviously, you have maintenance to be concerned with on those more sophisticated systems, but the consistency tends to go up.
Correct. Probably the most exciting thing that our engineering group looks at when they're looking at projects is exactly that. How do we eliminate the potential for human error? We get that defined down to the point that on a fully automated system, we have integrated weigh belt feeders to actually meter how much product is going into the plant, wet basis, as well as programming that actually does a feedback loop to the rest of the equipment, telling it to speed up, slow down, as well as letting us know how much product is actually going into that dryer, because we're actually manipulating the feed into the drying system. And so we want to know that the rest of the equipment is kind of lock, foot, and step along with that process. So we can get really automated and get rid of that human error. But we also do understand automation costs money. And so we do have the ability to simplify things quite a bit as well and still have some of those controls that we get good product coming out the back end. I'll kind of let Adam take off on the screw conveyors. Is that post shred at that point?
Yeah, this one is actually shows that, again, post, go back one more minute. There you go. Again, once it's been shredded, you can use a screw conveyor that's inclined at different angles, and it won't plug up the screw at that point, and hanger bearings are allowed for longer screws if needed without jamming. And we ran several million pounds of product post shredder through these without having the jams that we previously had on non-shredded product. Chain discs, once it's shredded and the right size, is another option that allows for a really tight footprint. And so you can go vertical with these as well as horizontal. And so, again, getting a tight footprint and getting as much elevation as quickly as possible, a chain disc is an option once you get to dried product. It wouldn't work on the wet side or pre-dry.
The statement up there, dried clean product, it needs to be dried and clean. We cannot have stock stem inside that process. This would be a great way to deliver post-drying to an extraction system. So if you needed to very quickly come out of multiple hoppers, we have multiple pickup points, vertically go straight up across the room, and then we could have multiple drop-off points at that point. We utilize gates to have multiple discharge points. But there's an enormous amount of flexibility, and the cost is relatively comparable to, in the past, we use a lot of flexible helical-style augers to do that type of work. But we need distance at that point because we don't like exceeding around 45 degrees on that type of equipment, just because you get a lot of flow back on flexible augers at that point. You start breaking down the product even more. Some extraction facilities or extraction manufacturers don't want their product to extremely fine powder, and some do. And so it depends upon what we're being asked as far as that particle size distribution to the extraction that will also play a role in that type of equipment.
Right. I think this is probably the type of conveyor that folks are least familiar with. A lot of people have seen obviously belt conveyors and screw conveyors, but this chain disc is a pretty nice option because you can have a single system that runs multiple lengths and can go very long distances and is very effective at getting a consistently metered solid. So we really like this, especially being able to go straight up vertical. You save yourself a lot of horizontal space in constrained facilities. That's great. And it does bring up that issue you just mentioned about basically your conveyors are never going to be completely have no impact on the material, right? You could say that belt conveyors maybe have the least impact on the material. Maybe the screw conveyors potentially have the highest impact, especially if they're going around a curve or something like that. But fines production is definitely something to be concerned about, not only from downstream on the extractor, you have to deal with those fines. You have to make sure they don't go into your downstream product, but also just from, dust in the air, dust in the facility. So I'm wondering if you wanted to mention, that dust control. How is that applied on these different systems? Is there one that's easier to keep contained so that you don't have that sort of notorious hemp dust getting all over your facility, or are they all sort of equally able to contain that?
That's definitely an Adam question.
Yeah. So again, belt conveyors we're typically using on the wet product, so there's not a lot of dust there, and that's a non-issue on the wet product. Screw conveyors absolutely have dust. Typically, recommendation is dust ports at where it's being fed into, and there's some product is falling into a screw conveyor if it's not sealed up well. If it's sealed really well, that's great on a brand new system, but as the covers get removed from time to time, then your seals, where it was all sealed when it was brand new, that's one thing, but after years of service, it's not, you get more and more dust. So if you can tie, again, dust collection at the in-feed chute and then also at the discharge chute is where that's recommended. But then while we're on dust collection, you're also on storage bins as you're feeding into bins. You have to handle the displaced air as the bin's being filled. And so you'll put a negative on that and just make sure that air has somewhere to go without finding a leak when it's being pressurized. The chain discs, ABM actually manufactures the infeeds and discharges that are fully welded and sealed and dust tight. So those you wouldn't need dust collection aside from the discharge into vessels, dry vessels. And I guess one last thing on the chain disc, we've all been a little vague on the lengths. The chain disc drive standard goes something like 1,200 feet of chain, 12 to 1,800 feet, depending on the number of elbows. And we have yet to see a system that's anywhere near that, that kind of length needed. So anyway, that's a number to the long distances available.
Great. All right. Yeah, good to know, because that is a big thing for a lot of people. I think that some people have a little bit of hesitation about the conveying because of this dust issue, but it's great to know that there are options out there where you can really tightly contain that. I think that's especially important for folks that are in a GMP type facility, which we're seeing more and more of that GMP and even CGMP nutritional supplement manufacturing, where fines control is a big issue. So moving right along here.
And to expand on that, on the systems that we design, we understand not only how critical the GMP and house cleaning of the dust is, but we also, we take it from the level of lost product yield, and we want to collect those fines and make sure we get it back into the process. So every point that we create dust or potentially could have a dust leak in our systems, we actually collect and send back into the final product so that you get 100% return on that yield on your good usable biomass.
Right, and I'm sure that you could even divert that to a secondary process if folks had a more effective method of extracting that very fine particle material. It becomes a point of diversion, and I think that'll probably raise some people's eyebrows, especially in the cannabis industry. They're thinking about making hash and other things. We can talk about particle size reduction and size separation a little bit later in this presentation, where we can get some insight on that. And for folks in the audience that have been chatting, I'm trying to avoid creating any black boxes. If you continue to have that problem, please let us know. I think that there's potentially an issue with the screen share where chat boxes are coming over the shared presentation. So we apologize for that, but we'll try and keep it to a minimum. And that may mean I'll take your questions mostly at the end of the presentation. So thanks for holding with us. Let's see here. All right, let's talk particle size reduction.
So particle size reduction, I'll kind of take this from the beginning, and then we'll kind of see where this goes. I'm pretty sure Adam will step in at some point. Shredders, as we had mentioned, the shredding takes place at the beginning of the process. It's how we are actually getting the hemp to be a uniform size. Drying is more than just putting heat and air to the product and evaporating out that moisture. What it comes down to, and something that we take very seriously, is making something so that we are energy efficient, minimizing our BTUs, and still coming up with a good product at the end. And to do that, the first step is to consistently feed that dryer, but also have a very consistent particle size distribution. The closer we can have that particle size distribution going into the dryer, the more efficient that dryer is going to be. So we have kind of landed on a particular type of shredder that gets us a product that's an average, a little bit less than 2 inches in overall length, what it breaks that product down to. Then we will take that into the dryer, and then post-drying, we have seen the industry kind of land on 2 different products that kind of come up with similar results. And we can get a little bit more into that, but hammer mills have been a staple in the industry forever. Basically, it's a product that you got hammers that are going to basically impact the product and push it through, typically in this industry, about a 30 or 40 mesh screen. And that picture would be what you would see coming out the other side of that hammer mill. Hammer mills are set up either to be a gravity type system, or we can actually use an air swept system where we're going to draft a little bit of air through there to assist in cleaning those screens. They all have a little bit different function, but right now what we've seen primarily in this industry is more of just a gravity type hammer mill. We have a picture of the screen that is actually utilized in a hammer mill, and the primary function of the purpose of that picture is we are designing, and we have designed and have implemented what we call a biomass sifter or separator, where we're actually taking an individual component or piece of equipment at that same screen mesh size, and the functionality allows us to not only separate out stalk and stem from the usable biomass, but it also gives us the particle size distribution that is very equivalent to what you would see going through that hammer mill. So we're taking one individual piece of equipment, providing 2 functions versus taking 2 pieces of equipment to do 2 different things. And so that's kind of our immediate push. If we are just looking for 30 to 40 mesh product and we don't need that particle size distribution to be different, we will go to a biomass separator versus the hammer mill. You got anything you want to add to that?
Yeah, just on the shredders, the primary one is what we pointed out here on the wet hemp and pre-dry. If you've dried on it as another method and still have long stalks and stems, to feed it either the hammer mill or the biomass separator, you'd still want it quite, reduced from the, 2 foot long or 18-inch long stalks to 2-3 inches long. So we use the same shredder to feed dried product into and get it to a size the next piece can take.
Perfect, you're right.
So, that shredder handles, again, if you control the feed rate in and it's just a pass through, we've seen it handle an enormous amount of product just passing through.
Yeah, on wet basis, I think we've had it up to 9,000 wet pounds an hour going through that shredder. But he is correct. Something that has become fairly popular in the last 3 to 4 months is there's a fair amount of dried biomass that's been either hand bucked or it's sitting out there in bulk bags. And we've been cleaning that product up and giving back just clean biomass, usable biomass. And then we have a little small system that we put together that originally feeds the shredder. And then from the shredder, we actually will then feed the biomass separator and get the individual some really clean biomass, as well as separate out that stalk and stem. And that system as well is incorporated with a dust collector, so that we, again, we're reducing or actually minimizing any dust that is created, because any milling process, once this product is dry, it becomes airborne, and you really need to have dust collection to keep that product.
The fines float almost like smoke. if you haven't dealt with a lot of the really dried, once you start milling it or doing the separation.
Yeah, and that's actually also commonly a source of allergic reactions in facilities. We've heard is that over time people can, start to have a respiratory response to that hemp dust. So by keeping that dust contained, again, it's sort of a workforce health and safety issue, as well as, of course, you want to keep your facility clean and keep the maximum yield you can downstream on your extraction process. I just want to emphasize one thing on the shredder and the separator that you've been talking about, is that essentially this can replace hand bucking approach, right? This can allow folks to basically take what you might consider a branch type hemp and automatically continuously separate the stalk and stem out from the usable biomass, right? So this is a means of automating that system. And,
yeah, I've got photos, and we've got some photos in the later slides that kind of show that.
Great.
But you are correct.
Yep.
Yep. And so that's just key, because I know for a lot of people that's a pain point. That's a lot of labor. So by eliminating that, the value of these systems is really strong. All right, let's talk about drying.
So again, looking at efficiencies and minimizing the amount of energy used and the labor force, a lot of the processes out there now are batch process that are labor intensive to load, and then there's a lot of them are stationary. The bed depth is stationary, and you end up with some denser spots that are hard to get airflow through. And then you got hot spots where the air finds the path of least resistance and dries and gets crispy and burns the product. And then it's just, again, we're shooting for efficiencies and consistent product. So the fluid bed dryer uses mechanical vibration to try to agitate the product, but then we've introduced air below that. It's a perforated plate to help fluidize it. The product is fed into the center of it, and then there's a back blending agitation so that the wet product is mixing with the dried product to help dry it quicker. And the dried product is forced to the perimeter, and then there's a bed depth that's set where we're maintaining a product depth, and based on the air, a lot of factors, but mainly the mechanical agitation, the airflow, and the input, we get to control the retention time and how long the product's exposed to the temperatures to avoid over drying. But then also all those contribute to a consistent dry without these, the wet and dense spots. Mm-hmm. So as you can see in that video, it does an excellent job of keeping that product moving. And then we're monitoring the outlet temperature and controlling our burner temperature to maintain consistent drying. So if there was a disruption in the feed product, we would know it because of the weighing that we'd be doing on a bigger, automated system. But it's not going to just stay at a certain temperature and over dry and burn the product. It'll drop the burner temperature. And then there's also the differential pressure would change with the change in product depth. And so the fan, both the inlet fan and the suction side of the exhaust fan are on VFDs to help balance that and maintain a consistent airflow through the product. So
the ultimate goal on this type of drying is that we try to maintain a product temperature not to exceed 120, but we're more around 110, 115 degrees F. And we actually maintain that product temperature by monitoring our exhaust temperature. So exhaust temperature is one of our key factors that we actually increase or decrease feed into the dryer. We don't manipulate the heat going in through the dryer unless it's that last case scenario. So we have a lot of different fail-safes. But if we all of a sudden have an upset condition where we cannot continue to feed more product into the dryer to maintain that correct exhaust temperature, then the secondary step would be that product inlet temperature starts to become manipulated. And once that gets to failure, then the system actually shuts down the heat so that we don't have a problem. One of the big things in this industry that happened over the past couple of years is a lot of these fail-safes weren't in place, and we started to start hearing rumors of fires in different drying facilities. And so there's a lot of safety interlock steps that are a part of this system, so that we're making sure that we have a safe piece of equipment to put out in the industry. Right below this slide, there's microwave mixing, and I'll do a quick little explanation on what that is.
Well,
basically, it's used. Okay,
before
go
we
ahead.
move on, Jeff, I think it's just key to highlight the big takeaways from why use fluidized bed dryers over these, belt dryers and rotary kilns and some of those other processes.
Okay.
Really, it's all about consistency of product, so it's completely evenly dried throughout the system. It is continuously fed, so it's not a batch process, so it, you eliminate some of the labor needed there, but also that you're able to, essentially accommodate a relatively wide particle distribution and still come out with something that's very, has a very tight tolerance in terms of your moisture content, right? So you can optimize
Correct.
this with the clients to have a specific output. And what we really like on the extraction side is that what we know is that oftentimes these belt dryers and other types of dryers come out with part of the mix being overheated, and that contributes to darker color. It impacts the ingredient flavor in a negative way, and also can negatively impact your yields in the cases where that you really are overheating the product. So we really like seeing this consistency. One quick question though, how does the footprint of this type of dryer compare to some of these other, conveyor driven belt dryers or rotary kiln type dryers? Is it approximately the same amount of floor space?
That is part of the unique aspect of this type of dryer. It is for a large unit. So if I were to say I want to do 1,000 pounds an hour, it would be an 84-inch diameter unit. And if I were to want to go up to 8,000 wet pounds an hour, it would be two 84-inch diameter units. So we actually have the ability, because it's circular and we move the product from the inside out, it's about dwell time, it's about burden depth, and it's also about control of that product. And because we have a lot of different variables that your typical just flat deck fluid beds are needing to accommodate, we don't end up with dryers that are 60 feet long and 8 feet wide. So we do have the ability to put a really, it's a nice, confined, small area that we can do the whole drying process. I mean, it really is nice.
Right. So for facilities where
that's
footprint is
a bonus, but I would agree that the benefit is our ability to control it and minimize product degradation, minimize lost yield on our oils, and have that control that the customers are looking for. If they want 4% moisture, we can get them that 4% moisture. They want 12, we'll get them 12, 10. We have that ability, and we've got it defined so that we can control that.
Mm-hmm. Yeah, I would not undersell that for facilities and especially for farms where they're building buildings just to house the drying, having a smaller footprint than some of these other large capacity, especially when you get to the large capacity options. This is quite an economic footprint for the amount of drying you can do. So that's a big advantage.
Exactly.
But obviously, the tight controls and the ability to have very, very consistent product is the biggest benefit overall. So thanks for answering my questions there. But let's take a look at the microwave mixers.
So microwave mixing technology, it's a system that is designed by Merriam Process Solutions. And it has the ability to dry whole flour. We've done some testing on whole flour hemp. We've done a little bit of testing on some marijuana flour. And we have already implemented this technology into individuals that are looking to decarboxylate hemp pellets or hemp powder prior to CO2 extraction. By decarbing prior to extraction. Basically, the game that we're playing is we're not even bringing this under vacuum. We're just heating it up and increasing the efficiencies in the extraction process is the purpose of that. We do have the ability, and this is where it gets really kind of fun and interesting, is that this unit uses microwave technology to heat or dry the product. And it's very precise as far as we can hit a temperature and maintain that temperature. But we also change the environment by changing the vacuum level within that. So we can drop this thing down to 100 torr and get our boiling point quite low so we're not hitting it with extreme temperatures. This product has kind of pushed us into another realm that we're currently, I'm going to throw this out there, but we're working on it. It is an R&D that's currently in process, and that is that we're looking at actually getting into terpene collection and trying to collect 100% of all the volatile compounds and terpenes utilizing this equipment. And we've had quite a bit of success in that, and we're hoping to continue that research and have something available to market, hopefully by the end of this month. So we're really close to getting that finalized. One of the advantages of microwave mixing technology is it is gentle handling, and so it does have the ability to look at whole flour, smokable flour. It is very precise in that we can maintain and target a temperature, and immediately as soon as you turn that switch, we're at temperature, and when we turn it off, that temperature is gone. So we don't have that increase and decrease to temperature. The only, I wouldn't call it a disadvantage, but it is definitely something that is considered when you look at this type of equipment, and that is it does come with an extremely high price point. And so for that precision, you do end up having a little bit higher cost to dry.
Yeah, and that's often the case with these more high-tech, high-precision solutions. You pay a bit more, but you get capabilities that really you can't find anywhere else. So that's it's definitely something we'll be tracking tightly with ABM, and especially on that terpene capture side. I know there's a lot of interest out there in capturing terpene profiles that are closely reflecting the original aroma of the plant material. So we'll be looking out for samples, and we'll keep our audience updated as to how that testing moves forward. Moving right along though, let's talk about the comparative energy use of the different dryers. This is something that's very important to us. When we do our operating cost calculations across the board, we think that energy use is really under-evaluated in the industry, that we see operating expenses in a lot of facilities being very high due to energy use. So what can you tell us about the comparison of the fluidized bed option versus the other types of dryers you might see?
So Adam, I'm definitely going to hand this over to the engineer who's done all the statistical information. So Adam will answer on the efficiencies of the caisson dryer.
So yeah, so the results we know are what we have for the caisson fluid bed dryer. If you were to take the data we have on that table on the right and look at a pounds per hour versus BTU, or pounds per BTU, the closest competitor is about 11% less throughput than this fluid bed dryer from a BTU standpoint. Most of them are less than half the throughput per BTU, and some of them are as far as 80% less throughput based on BTU. And the data we're using is the published data from various manufacturers. So I mean, we've tested the caisson unit. We know how many pounds are going through it and the BTUs being used. And this is just showing what's been published by other manufacturers.
Great. Well, very, very strong efficiency here in terms of your throughput capacity per energy input. You can really see the difference there. And over the lifetime of the equipment, again, the equipment might be more expensive up front, but you got to look at a 5-year business plan, especially in this industry where competition is so strong. the energy costs, be it electrical or otherwise, that's going to impact your bottom line very strongly. So having a competitive edge in the energy cost per pound of throughput, that's going to give you a cost either on a service offering or on your internal biomass that you're handling. It's going to give you a pretty strong operating cost advantage in the field here. Now, this is the very, very interesting area, the sorting or separation of different materials. Let's dig in. This is where you're potentially eliminating, things like hand bucking, and you're able to come out with a really nice extractable product after you're drying. So let's talk about your sifters.
We really have. We've worked closely with Caisson Corporation extensively on this platform. Utilized a lot of their equipment that we've had in other industries that did similar applications, but needed a fair amount of modification to get to this end product. Anyone that is in hemp or cannabis very quickly realizes that it's a product like no other. I've watched it break equipment for the last 5 years. It is an amazingly strong product. But the fun part is that between Caisson's engineering group and ABM's engineering group, we have come up with some equipment that is been proven in the industry. We've had a lot of hours of trials as well as processing plants that are now currently using the equipment, and it works great. Starting with the sifter, the primary product line that came from is a Caisson Centra sifter. The industry in which it was utilized was pharmaceutical, nutraceutical, the food industry, chemical industry. But the primary function was to take a powder and either deagglomerate the powder and or just sift out any over material and have good 30 mesh material come through. By changing up a lot of the internal components within that equipment, we were able to then take the shredded biomass, feed this into the equipment, and come out with a really clean, usable biomass that is very representative of what you would see coming out the bottom of your hammer mill. And that's primarily that screen that we initially talked about on that hammer mill, where you looked at that mesh size and the type of screen and the total open area that is utilized in that. It's not by accident that we manufactured a solid basket inside our piece of equipment that had a very similar open area. In regards to the other side of the industry, as we continue to go down this platform with Caisson, we started to see some of their equipment in bud sorting. We started to see their equipment in people that are utilizing ice hash. We did not know that our equipment was actually being placed into that industry. As the industry is becoming more, outed, or we're starting to be more open about what's going on, we've realized that this industry has created a market for our product with some slight modifications. So we now actually have the ability to take whole flower and sort it by size, utilizing their circular vibratory screen with different screen sizes. So that's kind of a fun little side bit that we kind of got into this industry, and we started realizing that we were further in this industry than we knew.
Right, and so one key thing I want to reflect there is you mentioned that your engineering group and the Caisson engineering group are working tightly on this. Is it fair to say that customers can find a customized product between Caisson and ABM that they won't find anywhere else, especially with this sifter technology? Is that,
Absolutely. It's even more, a little more integrated than that. And so at the highest level, there's an investment group that has created a platform called AMP. And AMP, under that platform, actually owns Caisson and Marion Process Solutions. And their objective is to throw their shoulder behind this and their resources to help the industry become a part of the industry and create equipment that is utilized in the industry. And so ABM's almost along for the ride. That's putting it kind of light. We do provide an enormous amount of engineering, R&D, the sales side of that business, but it's a really powerful group that's coming after the dry side of this business.
Mm-hmm. Great. And so yeah, keep that in mind. There are caisson vendors out there in the field, but ABM has a special relationship, has really proven this equipment out in the field, and is able to give, past track record showing very satisfied customers with, eliminating potentially something like a hammer mill and still coming out with a particle size distribution that's very equivalent, that's free of that stalk and stem material, and basically ready to go downstream to extraction, which is very exciting, very efficient system for that. So yeah, here's an example of the different sort of consistencies you can see on the input and output.
Yeah.
Walk us through here as far as what we're seeing. This is before and after, I take it?
Yeah, so that top row is kind of showing there's a whole lot more stalk in that feed product. This was forage harvested. The vast majority of what we've seen is about a third of the material is stalks and stems. This was closer to 40-45% stalks and stems. And so that the middle picture in the top is the fines that's removed, and it's got, the leaves and bud material that pass through as the fines are through that screen. And there's some, you can see in the photo, there's some stalks and stalk in there, but the vast majority is removed. The far right is the overs, or the stuff that didn't get pushed through the screen, and we had little to none of the desired product in the overs. And so the extractors we've talked to that have seen that are just incredibly happy with the results and getting out the garbage weight of the stalks and stems. But then it's also being used in other, the hempcrete or textiles or other industries where that fibrous material has mulch, different avenues for revenue. But it's separated without the good product. That bottom row is obviously much cleaner product feeding in. There was very, very little stalks and stems in the fines in the good product, and then the overs again had almost none of the desired product, and then you're just left with again stalks and stems. So it doesn't do 100% removal, but that screen size on the right is that 30 to 40 mesh. It's a heavy gauge. It's got reinforced rings down it. We'd seen some of the other screens on the market that were trying to do something similar that over time we're getting the metal was being flexed, and just the way that we've reinforced that and gone thicker, it's holding up very well.
Mm-hmm. Great. Well, so as far as that bottom left-hand picture there, you seem to have a lot of rocks or other material in there. Is that being removed before it goes into the sifter? That really the chunky, earth, or what can you tell us about that?
That chunky material is actually dried biomass. So it is, I guess you would consider it flour that is dried, and that product had been sitting in a bag from last year, and so I pulled out that
compacted
product, and it is packed up, and that's kind of the unique aspect of the biomass sifter is, like I said, it not only separates stalk and stem, but it also liberates the product, breaks it up, and allows you to not lose any of your usable biomass. There's a lot of screening manufacturers out there right now that are not being as forward thinking, and you'll see your overs that actually have good usable biomass still left in it. And so there's a lot of different ways to do it. You can put delumpers, you can put lump breakers in, you can put additional equipment in to liberate that biomass and then screen it out. Or as I was looking at it, is why not just build one machine that does everything? And that's what we ended up with, was a machine that could do everything.
Yeah, a very unique offering out there in the field. And looking at that bottom middle consistency, and really both those consistencies are usable, but especially that bottom middle biomass, that's definitely the kind of consistency you want to see going into an extraction process. So let's see, moving right along, you got to do something with that biomass after you've sorted it out. Let's talk packaging. This is, crucial for farmers, but also an intermediate solution that's necessary for any processors out there that are doing drying in their facility as well. So this is quite a sophisticated looking bag filler. What can you tell us about it?
This is about as high end as you can get for filling bulk bags. Again, if you were to say, I'm looking for a GMP facility, I want to know what my dry weight is out, and I do not want to create dust, and I need to be fairly automated, this would be that system. This system actually has what they call an inflatable spout. So you would actually take your poly liner and your bulk bag and put it up above a spout, and you hit a button, and almost like an inner tube, it would inflate inside that spout and create a positive seal. And inside that seal, you have a tube and a tube. So the product goes into the bag through the inner tube. The displaced air goes up and around the outer tube and to a dust collection pickup port. And so we're able to fill it utilizing a dust-free system. And we fill to weight. So if they were saying that they know they're going to have 400 pounds in each bag and they want exactly 400 pounds, we put 400 pounds in that bag. Like I said, definitely high end. This is equipment that is very standard in the food chemical industry and is built to meet those standards. We have done anywhere from building that type of bulk bag filler to a variation of all the way down to a bag hanger, where we will actually just provide a frame and some hooks, and you put those hooks on. And what we do is we will actually have the biomass sifter with a downspout that we will actually hard plumb up to that with a small little tube and a tube for just take care of that displaced air and run that off to a dust collector. This type of equipment would be how we would fill bulk bags. I've recently had some customers come to me and say that they want to fill drums, solid totes, and we can design hoods. We can make all kinds of different equipment to fill those and still maintain that clean environment.
Yeah, that's key. I want to emphasize there that, a feature that we don't often see out there in the field, but is very accurate weighing of the totes so that they're filled to weight rather than just filled to volume. As a bulk wholesaler, or potentially as a processor that needs to hit very specific input feed weights per hour, and you're coming out of these types of super sacks, having an equal weight distribution across all of your sacks is a very valuable thing to know, that every sack is interchangeable. Because out there in the field, we see that they often are not, and weighing each bag as you're feeding it in or something like that, that becomes quite cumbersome. Or if you're trying to sell those bulk bags, having to weigh them to know exactly how much weight you've actually got in that bag, that's something you want to avoid. So more expensive up front to implement something like this where you're weighing it as you fill it, but the payoff over time is likely to be pretty substantial. So I know we have a couple other items we wanted to talk about here as far as things like surge hoppers and intermediate containment. So what can you tell us about that? Maybe you don't need to go into bags. Maybe you want to go, especially if you're a processor, you're drying and processing on the same site. What can you tell us about other options we might look at?
Again, I guess from the screening process, or when before you go to either packaging or extraction, just a surge hopper allows for a disruption in while you're replacing the bulk bag. You need a little bit of storage time, and so that would it wouldn't have to be a huge amount of product, but some storage would be key. And then also just from a material handling standpoint, we could also put a diverter in. It would take it to either storage in the bulk bag or allow for direct to extraction, depending on if you want to accomplish both at the same facility. But then just the design of those hoppers is critical on hopper angles and then agitation on the discharge and different options to make sure you don't have bridging and plugging at the discharge of those points that we deal with in many other industries to keep your product flowing and not have, downtime.
Well, and if you're a totally vertically integrated processor, so you're going to dry and then also have extraction at the same facility, it's very possible we'd take it directly from cleaning it to a bulk silo or a bulk storage bin where we can actually store. They can get extremely large. You can get them up to the size of silos that are, your 5,000 cubic feet, or something that would be down to, 2,000 cubic feet. All things that we deal with on a daily basis, and we could actually take that product, put it into those bins. We can monitor how much product's in those bins. We can have the bins on load cells. We can have level indicators letting us know that bins are full, they're empty. And we could actually, then at that point, they could be drawing directly off of those silos or day bins right into their extraction process. Depending upon the environment and where those bins are located, we might be actually looking at injecting clean, dry air into those bins to keep that product good and dry. Obviously, we spent a lot of money getting it down to particular moisture. We don't want to let it sit somewhere and draw back in that moisture. So those are considerations we look at during that design build process.
Great, yeah, and that is key, knowing that the product's going to come in at the same dryness it went out. Obviously, one approach to do that is a big warehouse that's fully, air conditioned and dehumidified to get down to that optimal relative humidity. But the other option is having, contained and conditioned storage. We have heard also that fire is a risk in some of these bulk storage areas. So knowing that you have the option to, one, keep dry air flowing through there to prevent moisture buildup that can lead to overheating, but also potentially to inject some other gases into the system to inert that environment, especially on the large bulk storage. That's something that obviously we would always consider. And we think that skipping the bags is, again, it's going to save you a lot of labor. If you're going to use it on the same site you're drying it, just keeping it siloed, keeping it in bulk bins or in staged hoppers, that can save you, folks having to use bobcats, and you need a lot of forklift operators going to be running all day, bringing totes to and from your process. So being able to just meter directly out of bulk storage is something that's very appealing, especially at the larger end of the scale. So let's take a look here at some specific, applications, and walk us through here this diagram on a post-harvest drying process.
Yeah.
So just starting from left to right, you've got an in-feed belt conveyor. It's kind of hard to see, but a magnet. That next device is the shredder. So you want to protect those, the teeth in the shredder from any rocks and ferrous material. Not that it'll catch rocks, but a lot of the rocks have ferrous in them. And then from there, we're using a screw conveyor on this application to take it to the primary. So this would be one of those higher rate systems, 5,000 to 8,000 pounds an hour, where we have a primary flash dryer. So that system in the bottom left is the blower fan, the burner, and the heat source blowing to the bottom of the fluid bed. And then off the exhaust of that, because most of that product is wet and agglomerated, there's not a lot of fines. And doing a high temperature bag house on that, it's expensive. The dwell time in that would be pretty short so that we don't burn the product. But you've got, on this one, it was a short ceiling height. So we've got a dual cyclone setup, pulling vacuum on the dryer. Out of the dryer, the primary dryer, we've got another screw conveyor feeding the secondary dryer. This would be at lower temperatures, a little longer dwell time, but taking it down from 25 or 30% moisture to the 10, 12%. because we'd expect more fines on on the secondary. We've got a bag house that's catching all those fines, and then allowing it to be reintroduced and used. And then from there we go out of that secondary. Again, it's a screw conveyor feeding the screener or the biomass separator, where we separate out the fines versus the overs, or the leaves and buds versus the stalks and stems. So a fairly straightforward, complete system.
Mm-hmm. Great, and you can
I know
see
we're running
here,
at it.
yeah, and you can see here sort of that geometry in the fluidized bed dryer, that you're essentially kind of creating a vortex in there, right? Where not necessarily a true vortex, but you're creating a situation where essentially the biomass is spiraling out from the center where it's being introduced and then being ejected on the outside once it's reached a target dryness. Is that fair to say? We had a question about the geometry of the bed dryers.
No, that's very fair to say. So if you were actually to visualize what's going on inside that dryer, you drop the product into the center of that dryer, and as it dries, it would, if you were to picture a donut, it would be going on two different axes, one going up and over the back side of itself at the same time of rotating clockwise. And as your product dries, your density changes within that product, and the lighter density product continues to make its way to the surface and more quickly works to the outside edge of that product. So as we start to dry, the drier product very quickly starts to come to the outside. At the same time, you're doing all that back mixing, so you're utilizing other product to dry product, which is a very efficient way to do that. So absolutely, there's a lot of dynamic motion going on inside that, utilizing air and mechanical vibration, creating that movement. But as that product density changes, it changes position within that dryer.
Great. Well, let's see. I think, yeah, so that was.
I think
sorry,
that this would have been the other way to do it.
Sorry.
Hey.
Oh, let's go back to see that conditioning design here. Yeah, so this is sort of another more sophisticated multi-stage system here. What are we looking at?
So this is a great example of a system that not all systems are going to be the same. And what I always say is that sometimes we look at a system, and then in our mind, what we come up with sometimes doesn't quite fit the bill, because maybe the building, an operator, they have two different buildings. Maybe the distance between where we're taking the product, where we're drying the product, and where they're extracting are long distances, short distances. And so we will utilize just about everything in our bag to move product from A to B. Where this slide really dictates a whole different spectrum, and we've only had one application where this actually came into place. But we were actually dealing with an extractor who was buying dried material, but that dried material still had a lot of stalk and stem in it. And what they were seeing is that they were wanting 10% moisture product. They wanted to get that product down to 4%, but they were really receiving around 18 to 20% because there's a lot of stalk and stem left in that bag that leaches back moisture back out into their biomass. So this process actually shows us bringing in that material, cleaning that material, then milling that material, because we had to get that material down to the particle size distribution that they wanted. Then we actually dried it. And once we dried it, we needed to then get it back to the extraction process. So then we were actually using pneumatic conveying, where we would use air, because they were 150 feet down the way, two rights, two lefts, and one floor up to get to extraction. And so by that time, it just made sense to utilize air to get from A to B. And so that's how we kind of did that. You got anything you want to add to that, or?
Well, that's a key point there. So you mentioned that you use a pneumatic conveyor for that. So that's something that we didn't really touch on earlier. Maybe you could touch on what scenarios you recommend pneumatic conveying versus other types.
Just there's a lot of flexibility with the pneumatics. we've got a couple of different blowers, but we've got a number of destinations as well. And by changing some valving and diverters, this also had the feature of if the product had come in dry enough, we had the option to bypass the dryer and just go straight to extraction. And that's where pneumatics, and I've got storage in between that option where it's diverted. It's item 1.1, but where it's showing storage is, an option between the additional drying if needed or straight to extraction if it had come in at the desired moisture content. So long distances and then multiple options. This would have required a whole lot of diverters and different chain discs and different drives with those options.
When systems get extremely long, it's also if you're starting to look at GMP and cleanability and maintenance, pneumatic conveying, it has its place, but it's expensive. But you're guaranteed your lines are cleaned out. Your efficiencies as far as from A to B on long distances, they start to pencil out and make sense. From the mechanical aspect, you're using air. So you don't have to worry about screws breaking, pucks breaking, introduction of a foreign contaminant into the process. So there's plus and minuses, and those are these are all options that are on the table when you start. And as that customer works through his process, and we work through what the need and the fit is, we come up with the best solution for the best of breed for that solution. Is kind of the game.
And you can do pneumatics as a pressure or a vacuum system. This one's laid out as a vacuum because it contains the dust. And so the dust collection talk we had before about on different types of conveyors, this whole system's under vacuum and keeps the product under vacuum and doesn't have that dust, the dusting issue.
And that's great. I mean, so key thing there for when we're talking about diversion valves, if you have a very complex system, maybe you have multiple extraction lines, say you have 4 separate process lines that are running simultaneously and you need to source it from the same point of storage or even multiple points of storage, pneumatics becomes a good option there because you can essentially automate the system to switch where it's going dynamically based on which extractor is calling or which hopper is calling for more product, right? Could you achieve similar results in a shorter distance with something like the disc chain? Or is it really pneumatics is the best and only option for something where you have a complex routing?
If the product is cleaned, absolutely the chain disc system from an economical standpoint and the ability to do the distances makes total sense.
Yeah, so there's some interchangeability between there, but the pneumatics has that cleanability, advantage. And also when you need to do the maintenance, if you have for whatever, or inevitably, eventually there'll be some kind of a breakdown in the system. With the pneumatics, you're really just dealing with your pumps. Whereas with the disc chain, you've got the actual discs and chains to be worried about maintaining, as well as the drive mechanisms. So perhaps from a certain perspective, the maintenance of a pneumatic system is somewhat more, if not simpler, it's at least more centralized.
A lot less moving parts.
Yeah. Great. Well, I think now we'll go to questions, and I'm going to stop sharing my screen here. And I want to thank everybody for your patience. We did try and answer some of your questions as they came in, but I was trying to keep the screen clear, having problems with my share screen function there. Let's see, going back to the very beginning here, we had a question about shredding versus chopping. And I'm not sure exactly what they mean here by chopping, but maybe you have a better idea than I do. They're asking if there's a reason why chopping is not recommended for handling wet material.
The shredding does, it seemed like regardless of the in-feed product, the shredding took care of all of it. I'm sorry, the shredding. The chopping sometimes worked, but also you'd end up with some knots and things entangling in the what they're calling chopping.
It's chopping like a chipper.
Yeah.
When we first started into this, and I'll be honest, I thought it might be a great way to go. I was looking at a chipper, like something I throw my branches in, and now come all these chips. So I'm guessing that's what they're talking about with chopping. I've seen it out there, but your consistency is what we weren't getting the consistency, which was creating inconsistencies on our drying. And so by going with a shredder, we very consistently cut the material versus chopped it. So we had good cuts, and we were very consistent on our particle size, which is really critical if you want good, efficient drying.
Great. Let's see, I see a question about the energy usage of the microwave technology. Now, obviously, this is dependent on the scale, but is this, as a drying solution, is it energy consumption competitive, or is it really just the capabilities? It's going to cost more energy, but the capabilities are unique.
Do you remember what we did? We did an analysis. Off the top of my head, I don't have the answer.
We'll have to get back to you on that one.
That one we'll have to get back. We actually did an analysis, and I want to say that we did it off the assumption that we were going to be drying 4,000 pounds an hour, wet pounds an hour. So we can get that, and we'll have to feed it back. We apologize. That's not an easy equation that we came up with there. So
yeah, so it's probably not astronomically high, because you would probably have remembered that, but it's also probably not the absolute blow it away.
It was not the low end, absolutely not. But it was not the highest. The highest that we've seen out in the industry, and it makes total sense, is that some of these large drums that are using 32 million BTU to dry the product. And that type of equipment was originally, kind of put out there and went after the large aggregate industry. You want to dry your, DE and get that going, and you need a lot of energy to do that. But for agricultural products that, you're looking at leaf, it's kind of throwing grenades at a project that you should be shooting 22s at. So.
Fair enough. I see a question that I might be able to answer, and you can answer perhaps from experience in the field, comparing vapor barrier super sacks, so tightly sealed super sacks, versus more loose totes that have a loose vapor barrier that allow for humidity to come in and out. From our point of view, we typically prefer to see totes that are, well, it totally depends on the application, first and foremost. But generally speaking, vapor porous type of totes, if you have a air-conditioned environment, if you have a tightly controlled warehouse environment, is going to avoid any chance of condensation or any chance of differential in humidity between the outside of the material and the inside of the material. So that is an advantage from our perspective. That said, if you don't have a really good climate controlled storage environment and you are trying to keep your humidity even after drying in your bulk storage, then something that is tightly sealed might be a necessary option, because what you don't want to do is not have a vapor sealed option, and then you're just throwing it into 80%, 90% relative humidity and expecting it to be dry when you put it into your extraction process. That's just not going to work out for you. Is that fair to say?
Yeah. You nailed it.
Yeah. Great.
Yeah, it'll draw. I mean, just furthering that, it'll draw in the moisture from the the humidity in the air. So we'd had stuff we dried, and if it doesn't have the vapor barrier, it then gets wet.
Right. Yeah. So it really comes down to what environment you're storing it in. That's the bottom line there. Let's see. So there's a question asking about the similarities and differences of industrial hemp versus, say, regulated cannabis for other markets like we might see in Canada and otherwise. I think the key there from our perspective is terpene preservation is such a higher priority in that regulated cannabis environment. Obviously, it's sometimes very important for specific hemp projects where you need a high terpene yield. So that's not to be said as a totally broad statement. But oftentimes slower, more gentle processes are what we see in that regulated market. Obviously, the other big difference is you're not going to shred necessarily your recreational product because you want it to be in large bud format, unless you're going to pre-rolls or something like that. But I think this microwave project that you had was initially sort of focused on that more recreational medical industry segment. So what can you tell us about what drove the thinking behind that application?
It's actually the customers kind of driving the thinking behind it. So originally, absolutely, when we originally went into looking at large commercial drying, terpenes and the talk of preserving terpenes it doesn't come up. But as you start to focus in on a couple different strains of hemp, as well as the marijuana side, terpene collection and the loss of terpenes is huge. As the industry grows, and it's going to grow and it's going to continue to grow, at some point we're going to have to come up with a method to not only have the material dried, but we're also going to have to be able to preserve the terpenes and all the compounds within that material. Because we are so controlled on that wave mix, I mean, we are controlling, everything about that. And if we control from the point of hand cutting that flower and getting it into that system, we can minimize the loss of those terpenes. And if we have the ability to collect them all, then what do we do with them all? And that's kind of that magic thing right now, is that do we want to just collect them all and know that with that individual flower that this is the effect that that flower has, and that's genetically why we grew that flower. So we take 100% of that and just introduce it to something else or back to its product, that might be good enough. I see this industry going a lot deeper than that. So we're still kind of playing with what that end result is. But right now, it's a matter of wanting to collect all the way down to those monoterpenes that, how far back can we go and collect? Is it, you lose them when they're sitting in the field. You lose them in the morning. And so there's a lot to learn, and we're learning that process. And I think we're going to be playing with this for 5-10 years, to be honest, to figure out where it's going. The microwave or the wave mix has a lot. We've done a lot of testing, and we have proven that we can do a really good job of collecting just about 100% of what we're taking out of that flower.
Mm-hmm.
So,
and how do you compare that to something like the fluidized bed dryer? If you did have a big hemp client that wanted to capture the terpenes coming off the drying process, is there a wet, obviously it might be difficult to separate the water and the terpenes, but is there a method that you have out there for capturing what's coming off of the drying process on the vapor side?
So on a large scale drying or a commercial sized drying process, I am currently, Cason is kind of leading the charge, helping me through this process, but we are actually looking at low temperature drying. And we can do that with wave mix as well. And so we're going to have the ability to look at small batches, which would be more the wave mix size, or larger throughput potentially, utilizing the fluid bed and using more of a desiccant type drying system, where we're low heat, and heat is the killer when it comes to some of those monoterpenes. And so we're still working through that process. If we can do a low heat and then utilize a bag house or a bag top type dryer to collect any of those terpenes that we might have come off and then be able to reintroduce those, that could be a very good possibility. Right now, I say we do a very good job of trying to maintain the quality of the product, but at the same time, right now we do need heat to evaporate off that moisture. So we are losing some of those terpenes.
What about in a case where you might have concerns about odor in a drying facility? Is there an odor mitigation strategy for the vapor exhaust on the drying systems?
There is, and it's
Yeah.
expensive.
Yeah, it's called a scrubber. It's basically a wet dust collector. It's a pretty expensive option. But yeah, we can.
I'd recommend finding good neighbors and going.
Getting further away from the
Get rural.
yeah.
It's $1 million solution. I mean, it gets very expensive. But yes, we have actually had a couple customers talk to us about it. We have passed them along to some of those large industrial scrubber companies that can clean up that odor.
All right. Well, something, of course, we'll keep track of as it goes forward. Somebody out there is looking for that low-cost replacement solution, I'm sure, and working on it. Here's an item, a question from the field. Do you have any decarboxylation systems, say that going from drying to decarb? Now, so I'm assuming they're talking about decarb in the plant. They may have missed earlier in the conversation where you mentioned that the wave mix, the microwave dryer is able to decarb as part of the drying solution or after the drying solution. What about any other options? Is that the main option you go to for decarbing on the plant?
We have also utilized a batch style fluid bed dryer, so we can actually fill a batch with the powder or fine material and bring it up to temperature for 30 minutes to do some of the decarboxylation as well. It's going to be very similar to some of the ovens, vacuum ovens that you see out there. Obviously, because we are doing it with the fluid bed, our temperatures are a little bit higher, so that starts to be a concern on that, versus the wave mix allows us to go under vacuum and actually get that, so we're not putting as much temperature to that process, but still decarboxylating.
Mm-hmm. And that's an interesting point around the microwave, is that you're essentially directly applying the energy to the material rather than having to convey it via convection. So that allows you to very efficiently transfer all that heat energy basically into the trichomes. It's at the surface of the leaf. That's an advantage of the microwave. So definitely potentially has a more energy efficient profile for doing that decarb, where oftentimes it's quite a long decarb process in other options, especially when you do it in the oil stage. You're sitting there at a high temperature for relatively long periods of time usually. So nice to see an option for folks like the CO2 extractors out there in the industry that want to decarb upstream, or for whatever reason, if a company wants to decarb in the biomass. Let's see. Well, I think we have time probably for just one more question out there. So I think we've gone through most of what we've had thus far. If anybody else has any other questions, please do submit them now. Otherwise, we'll be signing off shortly. So in the meantime, I think we'll probably just close it out now. And I wanted to give a moment to give our thoughts to those that are affected by the wildfires across the country today and over the past week. And we know it's impacting families in the growing country across the West Coast and elsewhere. So our thoughts go out to you. We're hoping that these fires get contained and that the impact on the industry is mitigated. So for those of you whose families may have been affected or your business may have been affected, we're keeping our best hopes with you today. And otherwise, we did want to let everyone know that Sci-Fi Systems and ABM have begun listing equipment on each other's websites. So you can visit sci-fi-systems.com or it's abmequipment.com. Is that right for ABM?
That's correct. Yep, that's correct.
To find out more information about either of our products. And you may have told from the presentation, we can mate our continuous extraction processes right up to the end of the ABM conveying lines for continuous extraction. So we really view these systems as being the optimal solution for bulk storage conveying into a continuous extraction process. We think that really is going to lower your operating expenses substantially, lower your labor, and allow your business to be focused on optimizing your process and making sure that your maintenance technicians become the emphasis rather than having a large labor pool that is very complex to manage. So that's the next generation of the industry. We've seen the real market leaders out there going that direction. So we'd like to thank ABM for working with us on being able to provide some of these bulk handling solutions and drying as well. So thanks for coming on, Adam and Jeff. Any last points you want to make?
I don't have any points, but thank you very much for letting us be a part of this process, Emmett. It was awesome. I'm really excited and looking forward to working together as we continue to go out there. We will have improvements, and we'll feed them back through Sci-Fi and let people know where we're at, and we'll kind of keep growing.
Excellent. Well, we look forward to staying in touch and putting these out in the field. And one last thing to emphasize is that ABM has extensive experience in the field with hemp, putting these projects out there to completion with satisfied customers. So don't think this is hypotheticals. We're talking about real world experience, and your business could benefit from that real world experience today. So please reach out to us, either Sci-Fi Systems or ABM, if you're interested in going to automated conveying, drying, bulk materials handling in your facility. We look forward to hearing from you and seeing you on the next Plants to Plants in 2 weeks. Look out for our announcements on Instagram and on our website as far as the next couple of presentations we're going to have on. And we'll be keeping ABM in the loop for future potential presentations as new developments are always coming down the pipeline. So thanks once again, Jeff and Adam, for joining us. We appreciate you coming on.
Thank you.
Thank you.
All right. Thanks, everyone, and have a good day.